So our next model was used to validate how well the X-plane move was doing compared to our other potential over-constraint options. And all of those were compared to the compliant model results. So we compared 12 typical methods used for over-constraining models to a baseline, which were the results that we got from the same model using compliant modeler. We compared it in 3 categories. The first one was the mean correlation to the baseline again being the compliant modeler results. And then also internally at DCS, we scored each of these based on their subjectiveness and their ease of use. So if you have a high subjectiveness score, it means it's a very subjective move. And if you have low ease of use, it means it's very challenging for a user to use. We believe that the X-plane move, while being second in accuracy to using bend planes throughout, the bend planes are very subjective and also very challenging to use, whereas the X-plane is very simple and very easy to use for new users specifically, and all users.
No, the X-plane move can be used on flexible or rigid parts. It's doing a best fit. It's not deforming the part. So it is not like the auto bend or the segmented bend or the compliant modeler. It allows you to have more than a 3-2-1 locator, and it will adjust the part to minimize the difference between all of the locators. So what Spencer showed you was that it is a pretty close correlation, and it's not as difficult to do and get more accurate results than less accurate results. In other words, you can locate that fender with a 3-2-1, and some areas of that part are going to overvary because you can't control the fender properly with just a 3-2-1. You can correctly locate it with the compliant modeler, but that requires a lot of effort. You can get closer with the X-plane move, which does not require a lot of effort, but it's still not bending the part.
On that same kind of topic, so someone asked, they have multiple 6-way pins and hole combinations, like an IP retainer to IP beam. Can they use X-plane move instead of bend moves?
Multiple 6-way locators. So multiple 6-way locator with tolerances, that part would have to stretch or shrink. And you can use the X-plane, but it won't stretch or shrink the part. It will give you the best possible position with tolerances when you have an over-constrained part like that. So my answer is yes, that it's better than using the 3-2-1, and it's easier than the segmented bend.
What about like the auto bend? How do you think the auto bend would hold up in that?
The auto bend, I tell people you only want to use the auto bend if you are over constraining it in your primary plane direction. Okay. So that's why, after that, you can, add extra moves and bend parts in the secondary and tertiary direction, or you can go compliant, or you can leave it rigid and best fit it with this new X-plane move.
So we're going to move on to this fender model. This is the same model that we used to benchmark the X-plane move versus 11 other methods, and then check how it did versus a compliant modeler results. So for this, we end up with a 4-4-3 locating scheme. So we have 4 primary, 4 secondary, and 3 tertiary. If I zoom in on any one of these, I'm just going to zoom in on this one up here. You can see we have a pin and then also a surface. The pin is acting as a 2-way. It's a slot. If I go over to the corresponding location on the fender, we have a slot there. So that'd be controlling 2 directions because we'd have 1 direction for the slot and 1 direction for the surface at that post, and so on for all the posts. And we have a 4-4-3 here, so I'll go ahead and open up this dialog. So again, we have all of our object pairs lining up with all of our target pairs. In this case, this is actually an over-constrained model. So we have more than a 3, 2, 1, obviously. So if I nominal build this one and I deviate it, and then we zoom in at one of these control locations, we can see it jiggling around. And to set this one up, all I had to do was select all my object points, all my target points, and then set the direction specifically for each one of those 11 pairs. Super simple. Gary, is there anything else to add on this one?
No. That's what you're saying. It's super simple.
Yeah, it's tough for me to lengthen out the explanation because it's just that simple.
There you go.
Now, when you're setting up the move,
Yes.
can you reuse a
good
pair
question. Yes.
for different directions?
Yes.
Yes, if you have a 4-way, just like with the 6-plane move, you're going to have to add that 4-way to your list twice, and it's going to have 2 separate directions under our list.
So that's a good question because that leans back to the other guy that was asking about a 6-way
Mhm.
locator. You would have to pick that object and target 3 times
Mm-hmm.
to treat it as a 6-way locator. One vector would be X, one vector would be Y, and one vector would be Z, or whatever direction that 6-way locator is supposed to control.
Okay, order. So this is something I thought you might have noticed.
That's a good question.
This is an important one.
Order does not matter. We're used to a 3-2-1, primary, secondary, tertiary. With this move, you can pick your objects and targets in any order you want, so long as the net objects and targets fix apart in all 6 degrees of freedom.
Yeah, you can't have like a 6-5-0 move. You do have to have something locating it because it is controlling 6 degrees of freedom.
Yes.
But
that's why I was saying,
Mhm.
in your simple boxy door model, you still had at least 2 up-down locators and a couple cross-car locators
yeah.
and a whole bunch of 4 aft locators.
Mhm.
It was interesting. I used it on a complex contoured door with just doing the gaps, but the gaps or gap and flush, conditions. And I didn't even think about primary, secondary, tertiary. I just wrote all my objects and targets where my gap and flush conditions were. And it fixed the door in all 6 degrees of freedom because some of the flush conditions were Z, some of the flush conditions were Y, the gap conditions were X, And then I did it on another part, and it was a banging around out in space, and I couldn't understand what was going on, and it was because it was under constraint.
So, in relation to that, is it manipulating the part in all 6 degrees of freedom? Is it translating and rotating the part?
Yes.
Yes.